Hi class, I'm not in today, so here's your ed puzzle on solutions, molarity, dilutions, and solubility curves. For today's class, you should be able to complete the notes and sample problems, complete the practice problems 1 through 10 and 1 through 5, and then lastly, complete the reading on Google Classroom to answer the parts 3 in your packet. Packets are up on the front table. When you're done with your packets, you may put them in your folders. So here's a review of the vocabulary words. Take a minute here to read through the vocabulary words to make sure you know the names and definitions. Alright, so here we go with our notes for today. So if you look, this is at the very front of your packet. So we talk about molarity. Expresses a solution's concentration. So on the blank, it should be concentration. The symbol for molarity is capital M, not to be confused with lowercase m. And what it stands for is it stands for moles divided by liters. Now this equation can be rewritten so we can have M is equal to moles over liters, but we can rearrange this so that liters is equals to mole divided by molarity, and then lastly you can have that it's mole is equal to molarity times liters. If I'm writing it on the screen, please make sure that you're writing it on your paper. So when we talk about molarity, molarity can be called molar or moles per liter because they all represent the same ratio. So make sure you get this copied down. So here we go with our first calculation. So we are using the molarity calculation. We want to concentrate the molarity. So a solution contains 1.5 grams of Cl2 in 25 milliliters of solution. What is the molarity? So we start off with grams and we have milliliters. So our formula that we're using is molarity equals moles divided by liters. Now currently I don't have moles and I don't have liters, so I need to figure out how I can convert my units grams here and milliliters to substitute into this formula. So I know that if I have 1.5 grams of CuCl2, I convert that to moles by dividing by the mass of copper chloride. So on my periodic table, I'm going to look up the mass of copper, I'm going to look up the mass of chloride, and I end up with 134.45 grams. My G's cancel out and I'm left with my moles, and it comes out to be 0.011 moles. The next thing I need to do is now I need to convert to liters. So I have to take my 25 milliliters to liters. So if you remember, 1 liter is equal to 1,000 milliliters. So in this case here, I'm going to take my 25 milliliters, I'm going to divide it by 1,000, and that's going to give me 0.025 liters. So now this is the great part. Now I have moles and now I have liters, so I can substitute in my equation. So capital M is now equal to 0.011 moles divided by 0.025 liters. If I put this into my calculator and solve it, the answer comes out to be 0.44 molar CuCl2 as my final answer. So go ahead and take a minute to copy this down. And now we're ready with problem number 2. In problem number 2, it says, what volume should 20 grams of copper chloride be diluted to make a 0.15 molar solution? So if you're looking at this one here, they want to know volume. So my equation that I'm going to have to use is liters is equal to mole divided by molarity. So in this case here, I don't have moles yet, so I have to convert this. But this here is already in capital M, so I can just substitute that one in. So when I go to substitute this in, I have liters is equal to, my molarity is 0.15 molar. And now I need to figure out my grams. So if I start with 20.0 grams of CuCl2, I divide it by grams, And because I use copper chloride again, you all should secretly celebrate. This is going to be 134.45 grams per mole. My G's cancel out, and I end up with 0.159 moles. So now I can take my moles I just solved and put it into the equation by substitution, 0.159. And if I plug this in and plug it into my calculator correctly, I end up with 1.60 liters as my answer. So if you're making solutions, or if you have Kool-Aid and you're making Kool-Aid, you know that you're putting some scoops into powder and dissolving it in water. And these are the ways that you can figure out the concentration of how much Kool-Aid is actually in there. So go ahead and copy this one down. So most of you have used this in your everyday life. You know that if you want something to dissolve faster, there's some things that you can do to it. One of them, you can put it in hot water, things will dissolve faster. If you cut it up into smaller pieces, it will dissolve faster. And if you shake or stir it, it's going to dissolve faster. So if you take a look at this, those are our three factors. On your paper, it looks like the screen. So on the next slide, you're going to want to copy down what that means. So temperature increases energy of the solvent, making collisions more frequent. Go ahead and copy that down. The next one is surface area. Increased surface area increases the number of collisions. So the particles are colliding with the solvent more, it's going to dissolve faster. Go ahead and copy this down. The last one is agitation. That's stirring, shaking, which helps to disperse the solute particles, increasing the number of collisions. Go ahead and copy this one down. Moving on to our next equation. Oftentimes solutions come pre-made or at a high concentrations, and you want to dilute them to a proper concentration. So since moles of solute before dilution equals moles of solute after dilution, M times V is going to be the equation where molarity 1 times volume 1 equals molarity 2 times volume 2. So we have our new equation here on the screen that we're going to be using. Now, in this case here, you don't have to have the units in milliliters or liters. They can be in any unit that you want. So you can skip any conversions that you need to do. So here we go with our first calculation. So again, our formula that we're going to use is M1 V1 times M2 V2. So the first thing I want to do is write down the variables. So the first one says how much concentrated 14 molar hydrochloric acid is needed to prepare 75 milliliters of a 1.25 molar solution. So if you take a look at this here, they want to know how much of the 14. So the 14 is by itself. We don't know how much 14 we need. So that's going to be my ones. And then way over here it says 75 of the 1.25. Those are going to be my twos. So now I can plug them into I know the concentration starting off at 14. I don't know how much volume I need of that. But I know I want a concentration of 1.25, and I have 75 milliliters of that, because these two here go together. So now it's basic substitution. To solve in, it's 14 molar times V1 is equal to my 1.25 molar times 75 milliliters. To get V by itself, you divide both sides by 14M, divide by 14M. So the 14 cancels out, and V1 is equal to 1.25 times 75 divided by 14. And when I plug that into the calculator, it comes out to be 6.7 milliliters. So the amount of the 14 molar I need is 6.7 milliliters. Go ahead and take a minute to copy this down into your notes. Here we go with our second example. Again, we're still using the same dilution equation, M1V1 equals M2V2. So in this case here, how much water should 100 milliliters of 18 molar sulfuric acid be added to make a 1.5 molar solution? So I have 100 of the 18 molar. So these are going to be my 1, and I don't know how much of the 15, so that's going to be my 2. So the variables are a little different that we are known right now. So we have M1, V1, M2, V2. So my M1 is 18 molar, and I'm starting with 100 milliliters. My final concentration is 1.5 molar, and I don't know that concentration. So I'm going to have to solve using the formula M1 V1 equals M2 V2. So it's going to be 18 molar times 100 milliliters is equal to my 1.5 molar times V2. Now in this case here, my variable V2 is on this side here. I want to get it by itself. So if I want V by itself, I have to get rid of the 1.5 molar. Divide by 1.5 molar. When you plug this into your calculator, 18 times 100 divided by 1.5, you end up with 1,200 milliliters is equal to V2. Now this doesn't give you the answer though, because it says how much water should 100 milliliters of 18 molar be added to prepare. So if you think of this as a container, your container has a total amount of 1,200 milliliters. But then you started at the bottom here with 100 milliliters of that acid. So you started with 100 milliliters. So in order to go from 100 all the way up to the 1,200 mark, you have to subtract these here, and you're only adding 1,100 milliliters of water. So this one was tricky because I wanted to know how much total water you had to add. Your total solution is 1,200 milliliters, but you started with 100 to start. So that difference, 1,200 minus the 100, gives you that 1,100 milliliters. So this here is your final answer. Go ahead and take a minute to copy that down. All right, on the next page in your packet are some examples for you to go through to solve. So let's go ahead and try the first one together, and then you can do 2 and 3 on your own. So it says, what is the molarity of a solution that's 50 grams of NaI are dissolved in 1 liter of solution? And number 2, actually I'm going to do number 2 because there's an extra step to it. If you look here, this is already in liters, so you don't need to convert that. This one here, you have to convert to moles. In our second example, what is the molarity of the solution with 10 grams of AgNO3 in 500 milliliters? So this one here, we need 2 conversions. So the first thing I want to do is I want to take my 10.0 grams AgNO3 and convert it to moles. So to find the mass of Ag, an N, and 3 oxygens. And when I find that out, it's 169.91 grams per mole. So 10 divided by that comes out to be 0.059 moles. So that's the first step. My second step, I need to take my 500 milliliters and change it to liters. So to do that, it's 500 milliliters divided by 1,000. And that's going to give me 0.5 liters. Awesome. So now I can go up, and remember this is our equation up here. Molarity equals moles divided by liters. So now I can go through and I can plug this in. So I'm going to have capital M is equal to 0.059 moles divided by the 0.5 liters. So when I plug this into my calculator, I end up with an answer of 0.12 molar. So go ahead and try numbers 1 and 2 on your own. Sorry, I mean 1 and 3 on your own. All right, so here we go. Hopefully you had success with those. I'll be checking them next class. So now number 4. Number 4 is a little bit different. We're still using the same formula, but now they're asking to what volume. So to what volume should 50 grams of KCl be diluted to make a 0.25 molar solution? So the very first thing here I have to do is take my 50.0 grams of KCl, And because I don't want it in grams, I want it in moles, I've divided by the mass of KCl. So that's 39.10 plus 35.45. The molar mass is 74.55 grams per mole. My G's cancel out, and that's 0.67. I didn't do that one on purpose, folks. Whoops. Moles. Now they already gave me the capital M, so I'm like secretly celebrating that I don't have to do something else. So now I can go right into my formula. And in this case here for volume, it's liters is equal to mole divided by molarity. So my liters is what I'm looking for. I have 0.67 mole divided by my 0.25 concentration. When I plug that into my calculator, it comes out to be 2.68. Whoops, I didn't want to. 2.68 liters is your final answer. So go ahead and try numbers 5 and 6. Alright, so I hope you had luck trying those ones. Now we're going to try number 8. Again, you can't really see this on the screen, my copy and pasting. So this is number 8 here. So it says how many grams of KCl should be used to prepare a 1.5 liter of a 2.5 molar solution. So in this case here, we have to use the equation mole is equal to molarity times liters. So my moles are 0.25 molar times the 1.5 liters. So when I plug that into my calculator, I get 0.375 moles of KCl. So that's the first step. I figured out how many moles. But they didn't want moles, they wanted grams up here. So if I want to go to grams, I have to take my 0.375 moles and multiply by the formula mass of KCl. So if I find the formula mass for KCl I did on the other problem, it's 74.55 grams. And when I multiply those together, I end up with 27.96 grams of KCl as my final answer. So in this case here, we had to find our moles first, and then we convert to grams. So this is our step that we convert to grams. So go ahead and copy that problem down, and then go ahead and try 9 and 10. And here's our last calculation we worked on. So looking at this here, our equation is at the very top that we're going to be using. So it's the M1V1 equals M2V2. This is the dilution one. So how much concentrated 18 molar sulfuric acid is needed to prepare 250 of a 6 molar? So again, the 18 is by itself, that's my 1. These ones are together, so this is the 2's. So when I set this up, I have M1V1, M2V2. So I'm going to plug in my values. So M1 is 18 molar, M2 is 6 molar, and my final volume was 250 milliliters. So to solve this, it's going to be 18 molar times V1 is equal to the 6.0 molar times 250 milliliters. I want V by itself, so I divide both sides by 18, divide both sides by 18 molar, and V1, plug it into your calculator, and the V1 is going to be the 6 times the 250 divided by the 18 molar. So I'm going to plug that into your calculator. You end up with 83.3 milliliters as your answer. So notice that there's no conversions in the second calculation to convert to liters. You only need liters in the first set of problems, or the first calculation formula. So go ahead and try 2 and 3, and then just remember numbers 4 and 5 have that extra step where you're going to have to figure out what is the amount of water that you're adding. So remember that has that extra step in it for you that you have to solve for. So go ahead and copy this one down. All right, the last thing that you want to do is you want to go onto Google Classroom, and you'll see that there's going to be a reading to complete. So part 3 reading is there. There's a graph in your packet that you should be looking at, and that's talked about in the reading. So they want you to answer questions there. They want you to write down the main idea of paragraph 3, the main idea of paragraph 5, and paragraph 7. And they want you to write a summary of 4 sentences. And then if you look at the questions numbers 5 through 10, they want you to answer the questions about where is it. So the key thing from the reading is you want to know is that if it's saturated, it's going to fall right on the line. If it's above the line, it's supersaturated, and below the line is unsaturated. And that's what you'll be learning about in the reading. So good luck on the reading. Make sure you have your packet finished for our next class. And always reach out by email if you have any questions. And good luck. Please make sure you have your work completed for next class.